Okay, this is a quick lesson on 4.1 and 4.2. The main things to remember are that all of your quadratics can have this form, y is equal to ax plus b, x plus c, and this form can tell you a lot about the quadratic. A tells you whether or not it opens up or down, this parabola. This one happens to open up, so it's positive A. And then if the absolute value of A is a large number, it's a narrower parabola. If it's a smaller fraction, then it becomes very wide. You can determine the axis of symmetry by doing this quick calculation. You take the b value, which happens to be whatever the coefficient of x is, and divide it by 2 times the a value, which is over here. Take the negative of that, and that tells you your axis of symmetry and your x value. Your y-intercept is simply the c. So 0, c is on the parabola. All quadratics have a parent function that looks something like this. This happens to be the axis of symmetry. The vertex happens to be the origin, and they're mirror images on the other side of the axis of symmetry, on either side. And the y value can either be at the lowest point or the highest point, depending on whether or not your parabola opens up or if it opens down. So let's look at this first one. A happens to be negative, so it opens down because it's a negative. By the way, your homework is the odd for 4.1. So when I do my calculation for my axis of symmetry, I just take the negative of b value. There's no b here. There's no x value. So b happens to be 0. So it makes it easy. X is 0. When you plug in your x value back into the formula, you see that the y value is negative 1. So we already know that it opens down because of the negative. We know our vertex by doing our calculation. And we know our axis of symmetry because it's the same as our x value for the calculation. So if you do that same thing for this one, the a value is negative, it opens down. The vertex, you take the negative b value divided by 2 times the a value. When you plug that in, you get this value for x. You plug this back into the quadratic and find what y is. And now you have your x and your y, which is your vertex. The x value also happens to be the same as the axis of symmetry. Same thing. When you look at number 6, same thing. A is negative, so it opens down. Calculate my x based on this formula. Plug in my x value into the equation to get my corresponding y value. So I now have my vertex. And x is equal to 3/4, or what you calculated over here. This happens to be your axis of symmetry. Let's look at this one. This is a negative, so you know it's going to point down. The vertex is going to be negative b over 2a. When you do that, it happens to be the negative 2 over ba happens to be where x is negative 2.5. This is also your axis of symmetry. So before you even calculate any y values, you can look at this one and notice that the axis of symmetry for this parabola is where x is equal to negative 2.5. So every value of x is negative 2.5 is my axis of symmetry, and it's also where it mirrors, the parabola mirrors. So we can stop right there because we know that this is the correct answer. Okay, let's look at the next part. It asks us to graph the function, labeling the vertex and the axis of symmetry. So if we want to graph it, first of all, we know a is positive, so we know that it points upward or opens upward. We can find our x value, which happens to be 0. When we plug that into this equation, we can find that our y value is negative 3, but we already knew that because negative 3 is your c value. So 0, negative 3 is our vertex. It's a minimum because it opens up, so the y value of negative 3 is your minimum. My axis of symmetry is when x is equal to 0, which is the same as what we calculated here. So it's going to be mirror imaged on both sides. Now, what you'll need to do to find out how wide the parabola is to choose one point and then solve in the equation for that one point, and we know that the other side is a mirror image, and so you can just basically flip it onto the other side. Here we know it opens up because this is positive. We use our same formula to find the axis of symmetry and also our x value at the vertex. In this case, it happens to be negative 1.5. So we draw our axis of symmetry of negative 1.5 here. And then we solve for y using the x is negative 1.5. And we get our vertex. And then we choose 1 point on one of the sides and solve, and then go ahead and draw our parabola. Here we know this is a minimum because the parabola opens up. Again, we did the same thing here. It opens down because a is negative. You can find your vertex by the same formula that we've been using. We find out that x is negative 2 is our axis of symmetry. Please keep in mind that sometimes the scale is not 1. In this case, it's 2. So we want to make sure we're mindful of that. And then we put our vertex by plugging our x value back into the original equation to find y. And we know that this is a maximum because it opens down. Now for 4.2, you're going to need to do evens for homework because 2 is even. But let's briefly look at the standard form or vertex form of an equation, a quadratic equation, is this form. Now this can become very handy because if you have this form, it's easy to see that the vertex is h and k. Keep in mind that there's a minus sign here. So if this was x plus 3, then h would be negative 3, right? So keep that in mind. And also that your axis of symmetry is where x is equal to h. So this is your axis of symmetry. There's another form called the intercept form where you have factored out these to where you can have an x minus p and an x minus q. Keep in mind these are minuses again. This form allows you to see that the x-intercepts are p and q. So where x is going to cross the parabola will cross the axis where x is equal to p and x is equal to q. If it's going to cross the x-axis at these 2 points where y is 0, the axis of symmetry is halfway between those 2 points. So that's easy to calculate. You can use the FOIL method, which you've used before in your life, to determine or to move from intercept form to vertex form by simply multiplying the firsts, the outer, the inner, and the lasts FOIL in order to get the total answer. It doesn't matter what order you do these in, actually, but FOIL is just a nice way to remember it. Okay, here it asks us to match the equation with its graph. We know that it's a positive, so it's going to point up, and that tells you right away that it's this, but just for completion's sake, we know the axis of symmetry is that x is equal to positive 2, because h minus k, so x is equal to positive 2 is our axis of symmetry, and our vertex is at 2, 1, 2, 1. So many of those pieces of evidence let you know that this is the parabola that matches that function. So here they want you to graph the function and label the vertex and axis of symmetry. Well, the vertex very clearly is 2, negative 1, so you can go over 2 and go down 1. Your axis of symmetry is x is equal to 2, so you can plot that. We know that it's going to be mirrored on either side of that, so we can plot 1 point and then determine the other. Negative 1 is the minimum because this opens up, this parabola opens up, and we always use the y value for our minimum. Down here we have another example. A is negative, so it'll open down. Our vertex is 4, 8. Remember that these are not by ones, so 4, 8 is where our vertex is. X is equal to 4 is our axis of symmetry, so we draw that, and then we choose 1 point and plot the curve. Here it asks us to label the vertex, axis of symmetry, and x-intercepts, which means that it helps to have it in x-intercept form, so it helps to have it factored out. In this case, we know it crosses the x-axis at p and q, which happens to be negative 2 and negative 3. Why is it negative? Because remember it's in the form of x minus p and x minus q. So These are positive, so they must be negative. So we go ahead and plot the points where it crosses the x-axis at -2 and -3, and then we can find our vertex. Our vertex happens to be halfway between the -2 and the -3 point, which is -2.5. We plug that into our equation to find out what y would be, and we find out that y would be -1/4. So now we have our vertex, we have our x-intercepts, we have our axis of symmetry, we plot one point on here, and then we can find the curve. Down here we do the same thing. A is negative, so it opens down. It's not really in the right form here, so we have to multiply it out, and we can put it in the standard form of A with B and C. So we know our y-intercept is the C is 0, so we know that that's one of the where it crosses the y-axis. But if we want to find our vertex, we go back to our formula we were using before, plug in B and A. In this form, we find out that x is -3.5. That's also our axis of symmetry. Please note that the axis here is by 3's on the x and by 6's on the y. When we solve for y by plugging in x, we get more than 36. So 6, 12, 18, 24, 30, 36. It's a little more than 36. So we plot one point, and we get it to intersect. And there you go. Now it asks us to rearrange the quadratic formula function so that it's in standard form. Here you're going to use the same methods that you used back in Algebra 1. X plus 1 squared is in the form of a plus b squared, which is the same thing as a squared plus 2ab plus b squared, if you remember that. So that becomes pretty easy. Then you distribute your 2's, -2's. Now I combine my like terms, and I get the final answer. Here you use your FOIL method. You have x squared, your -4x, your -2x, and then your +8. So when you combine the like terms, you get this. Again, you're going to use your FOIL method over here, and then distribute the -3 out so you can get your final answer. Okay, here it asks us to find the minimum and the maximum values of the functions. Again, that's where your vertex, it's the y coordinate of your vertex. So it helps to find either the c, right here you can find it, it's very clearly c, -4. Over here, it's not in the right form, so you could calculate it this way by looking at your x-intercepts, and then your vertex is going to be halfway between. Remember, we talked about that. So my vertex is -5. So when I plug -5 back into this equation, I can find my y value. In this case, my y value is -4, so it's a minimum. How do I know it's a minimum? Because it opens up. The A is positive. Up here, it opened down, so that would be at the maximum. So just imagine, you might want to just draw a quick sketch in your head to keep in mind whether it's going to be an up or down, maximum, minimum. Here it's negative, so it's going to open down. If it opens down, then that means that that point is going to be the maximum. Everything else will be below. So I did the same thing. I went ahead and distributed this out. I found the vertex, the x-axis, or the x point of the vertex is -b over 2a. And when I calculated that, I substituted it back into the equation to find my corresponding y value. So that's the answer to that. You don't need to do the word problems. Have fun.